Okay, so welcome everybody to this webinar. I will wait a little bit longer for more attendees to join, 1 or 2 minutes. And well, yeah, in the meantime, usually what we do is take the chance to talk about some upcoming events. In this case, today I listed those three. Well, I always start with another webinar, which is next week, coming from a colleague of mine, Alvaro Pajares. He will talk about sub-hourly meteorological data and how they can impact your PV energy yield. This goes hand in hand with today's webinar. So today we talk about challenges, and part of that is meteorological data. So if you're interested and you want to know how this can be done in our tool, this webinar is, I guess, very, very interesting. And well, another one which is kind of related to users would be my colleague, again, Alvaro Gomez in this case. And it's more a rated coffee. For the ones who haven't joined a rated coffee before, it's a shorter session in which a colleague of our team is explaining a certain feature of the tool and basically tries to summarize how this is done in the tool very quickly, and you can just follow along and ask any questions. And as we're only 1.5 months away from Intersolar, of course, any attendees, if you're there as well, we are at booth A4 330, and you're welcome to come by, discuss any topics, and if you want to see the tool, then of course we will present it there as well. And I suppose we have now 2 minutes. We are 2 minutes in, so let's get it started. First of all, what are we talking today about? It's going to be the engineering challenges and solutions in Northern Europe. Why Northern Europe? Well, basically, I'm Julian Scheer, a principal consultant at RatedPower, and I work for the Nordic market, for the DACH market, and the UK and Ireland market. And with many clients, we talk about certain challenges they have, and there's always the questions on how to change or find a solution for those in our tool in RatedPower software. So we thought it's just very good to maybe have a webinar about this and talk a little bit more about how these challenges can be solved and identify potential solutions here. I will talk about first the context. So very briefly, because this session today should be very practical, I not only want to show you our software, also work with other tools, open source data to really, see the entire picture and get full involvement on all the data out there. That's the idea. So in point 2, I tried to showcase today efficient land prospecting. That's one challenge. Various weather conditions are other challenges, and then complex terrain challenges as well. So these are the 3 challenges I will focus on today. And then finally, the Q&A sessions where we can discuss, and I will try to answer all the questions you have. And of course, feel free to drop any questions already throughout the webinar. You don't have to wait for that until the end. So first introduction for the participants who haven't seen our software before or they don't know what RatedPower is all about. It's a cloud-based software. The idea is to intuitively design PV plants, ground-mounted PV plants. We try to automate the designing, give you the option to make changes to that, upload data, but not only that, and also providing technical documents. So that's the last point here, giving you the information about reports, spreadsheets. So that's kind of the picture, the whole picture of our tool. And well, let's dive right into the context. So what are the challenges I mentioned already briefly in the agenda? So I will start with the efficient land prospecting. A lot of customers, they come to us and they ask about the accuracy of satellite images. Of course, if you only see the satellite image, you don't know exactly where certain borders, land zones, cadastre data are at. So I will try to tackle this today. Other infrastructure as well. So maybe you have some power lines crossing your area. So you really want to identify all the zones which impact your PV plant essentially. And this is of course not only related to the Northern European part, also everywhere, but especially in Northern Europe, we had a lot of feedback about this. The next point, we call it various weather conditions. And what do we mean by that? In today's session, I will focus on irradiance and temperature. And the idea is really to not only use maybe one source, but also to compare different sources and really get different data in the tool to make a better, have a better solution, a better result at the end, and don't just work with one set of weather data to get the most out of the energy yield we provide you in our tool. And then lastly, I mentioned already complex terrain challenges. So basically, we know there is land available. However, it gets more challenging in terms of there's hilly terrain, there are certain slopes, and you really want to know more about that terrain. So sometimes certain open sources like Google Earth, they don't provide the certain resolution and detail you might want. And that's why I again try to show you today how you can integrate other sources as well, and even go further and analyze the topography in terms of slopes, in terms of earthwork calculation. Perfect. Let's jump right into the showcase. However, before I do that, a little kind of workflow. I try to start first with the land prospecting. That's the first step. That's why it has number 1. In the second step, weather conditions. And then the third step will be the challenging topography. It will be a little bit back and forth. I will open our software. I will open QGIS in this case to showcase some of the open source data I'm usually using. And of course, you can use those as well. And that's why I colored also these on the right side in blue and orange, because the blue ones will be the open source data I'm using, and the orange elements here are like satellite images, for example, or PVGIS data sources. They are the ones we already use in the tool, so you don't have to worry about those. They're already integrated. But yeah, just to have here a comparison and see what we already offer and what you can take from other sources as well. So what I will do now is I will just open the software, and basically what I did for today, you can see the software cloud-based. For the ones who haven't seen the tool yet, basically we have a design iteration here. I call it the initial design for today, and I already have a certain layout here, but the question is, how did I get there? And the challenge would be now, okay, do I have the exact cadastre data? Do I use the correct boundary layers? Did I make sure that any restriction zones like buildings are excluded? And also, did I make sure that maybe any other transmission lines are respected as well? So these are the topics I had in mind when doing this layout. So as I mentioned, how to get started. First thing I did, I opened QGIS. This is the tool I'm using personally. And I went to a site in Finland, a certain location. I just chose this as an example. And I used free open source VMS, VMTS layers, and also XYZ tiles and vector tiles to kind of give me more information on this location. And I will now activate those. So these are these 3 layers here on the left side. And basically what I can see now is a couple of more things. I can see that if I zoom in here, I can see the exact boundary layers of my cadastre data. So I would know exactly where my PV plant area should end and where a new area starts. So in the next step, with this information ready, which is already like increasing my accuracy, I just made this selection here. I had polygons selected. I chose these 4 elements here, and they are basically the cadastre data I was interested in. And then I also saw that there is an overhead line, basically the Open Infra map, which I didn't include yet. It's basically a open source layer which tells me, okay, there is a power line passing through here, and we can see the kind of information in the QGIS layer here. And this just helped me to identify the exact area which I want to exclude from any PV modules. And I could also see, if I zoom in here, This are separate cadastre layers with buildings and probably landowners. So I also excluded these in my polygon definition here. Why did I even define polygons? Well, the idea is here that these are the areas I then upload to our RatedPower software to then work with these and plan my PV plant accordingly. And that was actually the first step I did. So these polygons, I just exported them as a KMZ KML. And in a second step, I then went to my software. So I'm back here and I just uploaded them. I'm just quickly showing how this is done. I'm just going to open our software in editing mode. We call it design process. And basically the idea is here, once this is loaded, that the KML I just produced, I will upload it here in Insight. So I can go here and just upload it as a KMZ file. And then this is already much more accurate than drawing it by hand. You can see here that the kind of cadastre parcels are respected. I also defined my crossing overhead line, and those areas are also excluded. So already now I gained a lot of more accuracy than just doing it with freehand drawing and just based on the satellite image, which didn't tell me any cadastre boundaries. Now I said that the next step would be the meteo data. So if I look at the tool here and I will open the meteo data, I will see that it automatically chooses PVGIS as a source, which is great. It helps me a lot. It doesn't generate much more work, so I don't need to upload my own file. However, now the idea is to not only use one source, but maybe make sure to compare different sources. And for that, I uploaded different meteo files, always in hourly resolution from different sources. You can see that some of them are PVGIS, just a different satellite, and the values, they differ. And yeah, finally, there's other sources as well, Meteo Norm, Solar GIS. So if you have any other sources available, it just makes sense to upload them and then maybe do a comparison on the energy yield and on the entire irradiance values for your PV plant. This looks very easy. How is it done though? I prepared those 2 pages I wanted to show you. Basically, first of all, there is the website from PVGIS, public of course as well. And here the users, they can go to a certain location. My location was west of Helsinki, somewhere here. And basically you can tell the tool, do I want switch to PVGIS version 5.1 or 5.2, and then when I select the location, I can decide which kind of sources I want to take, and then just very easily download the CSV file with the weather data, so global horizontal irradiation, temperature, and diffuse irradiation. These are the 3 ones we are interested in. And then how is it uploaded? Well, if you download it from PVGIS, you can directly put it in our tool, just upload it by using the upload meteo function here. Very easy. You just have to select which kind of resolution you have. And this is also where my colleague Alvaro will talk about the sub-hourly part. I used only hourly values here, and I just uploaded those. If you use your own weather station or maybe other sources, then there is a certain template, an Excel sheet. I also opened it here just for you to understand how this is done. The Excel looks something like this, very basic in that sense that you just need to fill in the 3 columns here. And for each hour of the year, you just have a value. And then once this is done, you can simply upload it to our tool as well. And this way you can pretty much get all the meteo data in your design. Now we covered the meteo data, but then how do we actually make use of them? So in this case, I will go back to our tool, and in our tool, easy. Supposedly you have PV plant already kind of defined with the parameters. I will run a design with PVGIS. This is the weather source which we use by default, and then I simply just select, in this case, PVGIS Sarah 2. And I just run the same design again. So it just keeps all the parameters the same. It just simulates those designs here on the right. And then I do that with pretty much all the examples here. I don't do it with all of them. I just, well, do 3 examples. So let me click on the last one here. Perfect. It should also simulate now. And well, these are already, when you got those data ready, it's super easy to generate those. We can see those designs are already done, they're already loaded. So we have 3 elements ready. I will save them here. And the question might be, why do I save that? The reason is that if I go out of my editing process, when I save them, I have them ready here, and I can now make a very quick comparison. So I can just take these data now, compare them. Remember, the entire PV plants remained the same. We literally just changed the weather data. So we can see this made a change. Okay, I can see that 2 of these examples are actually the same. So let's just use the example of 2 then. And we can see that basically we have different energy yield. This is the effect of the different weather sources. We can see a slightly different DC-AC ratio. Of course, if there's different temperature values, the software might choose a different length of string, so modules per string. So of course, the parameters can be influenced, but it's just the idea here to show that if you use many different resources, you can really simply integrate them, make a comparison, and then have a better justification for your energy yield. You don't have to just trust and rely on one source. Yeah, and I guess there's other comparisons you can do, but for today, I just thought about really having a quick look into, for example, the energy. You can see there is a difference already here in your yearly energy yield. And based on that, you can just make your assumptions then. So this works with weather data, but of course it works with any other parameters as well. And this would bring me now to, well, actually the 3rd challenge already. The 3rd engineering challenge would be topography. So the idea here is to go back to your QGIS layer here. And basically what our tool does, RatedPower, we upload Google Earth data, and we can see in a minute how they look when we use them. But we also know that sometimes these are not let's say, in a very high resolution. So what I as a user would be interested in is to get maybe a very detailed topography analysis of this plot. So what I did here, I actually looked at if I zoom in here, I looked at the cadastre data. I can zoom in here a little bit more, but I think it always adapts. Yeah. Anyway, I just used one of those codes here. It is the parcel number. And this parcel number just gave me information on where am I, and these information were helpful to go to a public source on the web, which is the national. Let me just really have a look quickly. The National Land Survey of Finland. As I'm in Finland, I was interested in the Finnish land survey, and what I did here is I put in here in the search bar, I looked for that parcel, and then I told the system that I'm interested in survey data, so elevation model data. And when I clicked on those, then basically I can see that the entire country is kind of split into certain parcels here. So I just had to click on one of those and then downloaded the raster file. So the GeoTIFF file, I just downloaded it. It was super quickly available. And then with this information, I can now upload a far more defined, far more accurate topography file to my tool, to our RatedPower software. This sounds very easy. It requires a few steps. These steps are again happening in QGIS, so you can really see that there is a very close link here. I can always work in QGIS as an example. There's also other tools, of course, but in this example, I can work with QGIS and then make use of these open source data and really just convert them and upload them to our tool. So there's a very easy workflow and very quick process, let's say. So what I did is, and I prepared this already for today, first things first, I uploaded the raster file. If I zoom out, I see that it is that block we saw earlier. And then I had to do a few steps. These steps are described in an article we will also share with all the attendees. Basically, the steps are reprojection. So you have to first project it to the right coordinate reference system. Then you have to clip it. So if I clip it, that means I just have to shrink it down a little bit. Otherwise, this file is huge, it's very big. So I just made sure that it only covers my PV plant area. I can show you the PV plant area here as well. So I kind of clipped it around. And then I just had to export it as a CSV file, so XYZ file. And then I was already ready to use it in my tool in RatedPower. So this process just really, in this case, with the public data available from Finland Land Survey, just really made it very easy to obtain very good topo data. So in a last step, I went again back to our tool, and I really hope this is not too much jumping back and forth. So I went here to my tool, and now I can just continue with my last design. I will again go into editing mode, into the design process. And basically, what I will do now is I will first run an example with the default data. As I mentioned in the beginning, our tool always provides you data. Okay, for the topography here, I can see that it's Google Earth. So if I run a design now, actually I have to wait until it's loaded. And I believe as it's loaded already, I'll run it again. I can just have a look at the 3D map. So the 3D map just highlights the integration of topography in a 3D view. So when I can already see that it is a little bit hilly. So if I move around, I can see that there is some valley, some areas where I run plenty module as an example. So this already looks good, but it also be accurate. I can see it's very first and want to know, hey, does look this if I use. In this case, what I did, so the raster data I just showed you from QGIS, I called them clipped topo. And if I select them now, I now have to run my design again, just so that those new topo data are also used. And let's have a look if this actually makes a difference, or if Google Earth already provided very good data. Let's zoom out here. And basically what I can see is it looks similar. Let's say there is a hilly terrain, but I can also see that basically the hills are much more refined. They're much more accurate. I can also see that this, and we saw this in the image of the satellite, there is a certain, kind of like drilling happening here, a mine, let's say. So this is now represented much better. And currently the software places the modules there because it, of course, knows the topography, but yet currently by default, it's not taking it into account. And in a second step, I will show you how we take the topography into account. But this example just also highlights, hey, this is a mine. I will exclude this completely from my PV plant area. So I would not even consider this part anymore. But just choosing these public data already gave me, again, solving this challenge of not knowing exactly where's the hill, how much elevation difference do I have. So just by doing this, I already gained much more information. I could now make a topography analysis much more accurate than before. And this will bring me actually to my last point already. It will be the analysis of the topography. So we now made sure that all the challenges I described in the beginning, so kind of land prospecting in terms of power lines, in terms of cadastre data. In this example, I already made sure this is done. Topography as well, the challenge of having accurate data, I solved it by not only using Google Earth, but also supporting it with another source. And then the meteo data, as shown earlier, I made sure that I uploaded different sources here and having those to compare with and making a more precise decision. So let's jump into the topography analysis then. So our topography tool, and I will then switch to the view again, just to better explain what is happening when we analyze topography. By the way, we can see here the mine again, so it was represented very well from the topography. So the first thing I can do here is I can basically apply certain slope limits, very straightforward. I can tell the tool I am interested in analyzing my northern slopes, for example. If I select this part here, it will be the same value for both slopes, northern and southern. But as I'm only interested in the northern, I will click this option and I will deselect my south-facing slopes. I'm not interested in those as an example. And I will now analyze that. I would tell the tool, hey, 10% as a northern slope is my maximum. beyond that, I cannot install my structures. And then in a second step, I would also analyze the east-west topography slope and tell the tool in east-west direction. I again, just assuming here 10% is my limit, and this would be it. I would just run the design now and just have a look on my results. And how do they look? So basically what we can see two colors. The light blue is everything which is not affected. It's basically on a flat terrain which is below those 10%. And all the dark blue areas here, they are the ones which are either 10% north slope or 10% east-west slope. So the software already highlights those. And of course, by making changes to either percentage number, I can adapt it and really reflect more what I'm actually interested in. But we will just take this example today. And basically, the idea is now that I can tell the tool, okay, this is great information. I see that it's quite flat in the mine, but I will just remove this area later on anyway, so I don't worry about this part. But this hill here and the part here at the bottom, they are very interesting, and all the others, of course, as well. But these are the, let's say, the major areas here. And now I can tell the tool the following: that it either deletes those. So I can simply just click on remove, run my design. Of course, in this example, it will remove a lot of panels because it highlighted them in many areas. But now I made sure that all the panels are removed, and I make sure all my panels which are remaining are still the ones on a flat terrain. That will be the quickest analysis and solution found. In a second step, and this is reflecting to the earthworks, basically we have the option now to go here and tell the tool, hey, you now analyzed those slopes, which is already helpful, but can you please also calculate how much cut and fill volumes I would need to flatten out this terrain? And this might not work for every element, because sometimes the slopes are very steep and earthworks just don't make sense. But in some other elements where it's not that steep, it might actually make sense. So if I now run the design again, just by having this example here, I will see the following. Now the 38 megawatt park is similar, and now we can see that currently it doesn't. That's interesting. It doesn't analyze any earthworks here. Let me just enable the other earthworks. I can see that I'm a little bit too restricted here. There is no flexibility here, so this earthworks number has to be higher than my limitation, of course. Otherwise, we don't have any calculation base. So let me just increase this now. And now I click simulate again. It's running again. And now it probably shows me what I was expecting. Yeah. So it now highlights all the areas where earthworks are possible, up to 20% slope. So this 20% now means that all these areas, they were higher than 10%. That was my initial analysis, and up to 20%. So this is the range in which I'm currently calculating earthworks, because it might just not make sense to go higher, because 30, 40%, that's just too steep to calculate earthworks. So that's why I just went with 20% in this example. And now the tool told me, hey, on this specific area, we have a certain cut and fill volume. And again, this can be just very helpful for a first estimation on how much truckloads I might need, or how much earthworks are actually needed. And with this information, I now again gained accuracy, because otherwise, if I would have chosen worse topo data, like for example Google Earth in this specific example, these calculations would have been different and not as accurate as with these high resolution data. And this, with that, I would jump back to the presentation and just wrap it up basically. So if I can move this slide. We're already at the Q&A session. I hope this was interesting for you. The idea really was to quickly show you how you can import different data, use open source data, and really make sure that you gain accuracy, maybe solve some of the challenges you have in Northern Europe, land prospection, topography, and weather data, and don't just rely on one data source, and really get the more flexibility and more accuracy in your results. And with that, I'm opening the Q&A session. Feel free to ask anything in the question box, and I will make sure to check them. Okay, I can see the first one is dropped already. Regarding solar databases for Scandinavia, SolarGIS versus PVGIS, etc. Do you have a benchmarking of solar data and PV design for Scandinavia? We got asked this question a lot because it's always a question, what is the most accurate? What we experienced is basically that PVGIS, they offer sometimes very close data. So in the southern part of Finland or Sweden or Norway, we realize sometimes these data match very well. However, if we move up north, sometimes there is not the entire country is covered by PVGIS. So in this case, if you have data from SolarGIS, then I would say that this is of course better because they cover the entire country. In terms of benchmarking, I just know that SolarGIS really tries to get the Nordics and Scandinavia in general covered, and many users use data from SolarGIS. So I would say a good estimation is PVGIS from the start, but I would really make sure to compare it. Also make sure with what data you compare it with, because of course, if you use hourly PVGIS data and compare them with monthly SolarGIS data, monthly values are always less accurate in the sense. So there's always the question of comparing the same resolution data, if that makes sense. I hope this answered the specific question. Of course, there's other sources as well, as I mentioned earlier, Meteo Norm. And if they are open source, if they are available for free, then it just, in my opinion, would make a lot of sense to just use them and just make a comparison very quickly, just to have more information on that. And then maybe you can even decide on your own private benchmarking database. Let me have a look. There's another question about because I showed the transmission lines. So the question was if we also, take into consideration the curtailment of the grid in a summary. That's a very good question. I mean, I showed you earlier the constraints like transmission lines, and of course we also take the kind of transmission or let's say the grid connection into account. I will therefore really quickly open the tool again. It's probably the fastest to explain it here. So the question was basically related to when I go back to my site, I zoom out a little bit here. I had the restriction zone, right? The red restriction zone here, which represented a transmission line. And me personally, I placed my substation here just as an example. And if you already know that your grid is limited, that's what the question was related to, you can go to the layout, to the power requirements, and you can tell our tool there is a certain energy clipping happening. So if you enable this, you can tell the tool that your grid only has a capacity of 20 megawatts. And then we will make sure that this is achieved and everything else would be highlighted as curtailment losses in this sense. So yes, you can take the grid not only into account by removing that part here as a restriction zone, but also as a curtailment. But great question. I will have a look into more questions. Okay, the other question here that will be about other losses, like we had weather data and the different impacts on this. And here it was asked if snow losses were taken into consideration as well. And I guess that's very true for Northern Europe. This can be a challenge and is a challenge. So I didn't mention these, and they're not, let's say, integrated in the Meteo data when you upload them as a user. However, you can go directly to our energy tab. That will be a tab which kind of covers elements related losses regarding PV module losses, albedo losses, so losses from reflection, and also soiling losses. And currently in our tool, you would here in PV module losses, you would simulate snow losses as soiling losses. So just by showing you really quickly what this is, we have our certain PV module losses, which we can change. And here as a bottom line, I can tell that my front face is either yearly, the yearly soiling losses are 2%, but in terms of snow, I might expect that on a monthly resolution. So in this case, I can define certain elements here, like in January, February, and December, for example, I would expect snow. So I can just type in here that either it really like 80% loss, for example, or 30%. So I can really just modify that here, and this will be directly reflected in my energy yield. So yes, currently snow losses are simulated like this. And of course, you can also prevent or make a good design in the sense that you either put your structure very high, so you can tell the tool that the minimum ground clearance is maybe 80 centimeters or 1 meter even, so you can make sure that the snow kind of can fall down and don't pile up in front of your PV plant. And all these topics we heard, and in making a good design in Northern Europe, you would take consideration of that. In terms of questions, great question so far. I don't see any other question. If there's no other question coming up, of course, again, we will share with you our web pages on how to import raster data from free available open source resources, and also on how to upload your meteo files. So you can always check that if you're a user of the tool. And yeah, thank you so much for the attention. Thank you for that afternoon session. And I hope to see you soon in the next webinar. Thank you so much.